In Cockpit, we aim to develop a methodology and a coding tool suite to enable citizens to participate in the design and redesign of public services. As you can see, our modeling tools are implemented based on Eclipse. The scenario I'm using as an example in this demonstration is based on an actual scenario from the Cockpit project. The public service we are going to model allows citizens to get an extract of their insurance record. We start to model by creating a new model in the Public Service Modeler. The Public Service Modeler allows to store generic information about the service, including its name, ID, requirements, related documents, and so on. As part of the service design, the Public Service Modeler allows to model service requests and processes that are designed to fulfill these service requests. Notice that the process modeling is based on BPMN. A unique feature of our tool suite is that it can be defined that decision gateways should be resolved during design time. The different flows that originate from such gateways then correspond to alternative variants of how the process could be implemented, thus expressing variability. In this example, the citizen could either take a token number and wait until his appointment, or he could call the customer service center and request an appointment that will then be scheduled by the front desk employee. To handle service variability, we implemented a dedicated modeling tool called Service Feature Model Designer. It is based on feature modeling and captures the variability of a public service in terms of service features corresponding to implementation aspects of the service. In the case of a design time decision gateway, a feature structure that corresponds to the path variant can automatically be created. It is also possible to model service features manually that correspond to any implementation aspect whose integration in the service implementation is under assessment. For example, resources, such as a front desk employee, can be modeled as optional service features indicating that they might be part of the service. Additionally, requires or exclude dependencies between service features can be modeled to ensure the validity of the possible service configurations. In this case, calling the customer service center requires a front desk employee resource to be part of the service as well. To capture value-relevant aspects of the possible implementation variants, we utilize attribute types and attributes. Attribute types define a class of attributes and capture properties that are valid for all its instances. For example, an attribute type costs defines that costs should be considered as value relevant. Attributes are modeled directly under the service features that they describe. They relate to a priorly defined attribute type and have a unique instantiation value. Based on the modeled service features, the Service Feature Model Designer can automatically determine all possible service configurations. The determined configurations are stored as part of the Service Feature Model. For each configuration, the Service Feature Model Designer also determines an overall value for each attribute type by aggregating all types attributes contained in the configuration. When a service feature model is completely modeled, including all variable service features, dependencies between service features, attribute types, and attributes, an evaluation can be triggered to collect stakeholder preferences. The Service Feature Model Designer provides wizard to publish an evaluation. The wizard allows to provide metadata to control the evaluation. For example, the targeted stakeholder group, the time frame of the evaluation, or its current state can be set. When an evaluation is running, the defined stakeholder group can state their opinions about the service design in a vote on the web-based deliberation platform. A vote is based on pairwise comparisons among all attribute types that were defined in the service feature model. By stating the preference for an attribute type among all pairs of types, an overall preference order for all attribute types can be determined. At the end of an evaluation phase, the service engineer can retrieve the overall results. For this, all votes are aggregated to determine an overall preference vector for the attribute types. Using analytical hierarchy process, the preference vector is matched with the possible service configurations, and in the Service Feature Model Designer, the service engineer can use the wizard to retrieve the evaluation results. The preferences will be stored as subnodes of the configurations nodes. The preferences state the stakeholder group of the evaluation, the time and date they were calculated, and the preference value. The higher the preference value, the better does the according service configuration meet the stakeholders' preferences. In this example, the first configuration with low cost of 5, throughput of 30, and home access supported is rated the highest by the citizens. The service engineer is thus hinted to implement the first service configuration to best fulfill the citizens' needs.